3, lesson 6. So this is the one that's following our really long calculator lesson that wasn't recorded. It was a little bit too long, and I think I want to piece it up, so I might get to that later, hopefully. Try to get that on there. But so now what we're going to do is we're kind of looking at more applied problems using our calculator. So consider a scenario from class example number 3 in lesson 3 of this unit. So Lisa purchases a new car. So this is the one we talk about the car depreciating, going down in value. So for 2,000, the value of the car is represented by the formula 20,000 minus 1250t, where v is value, t is age of car in years. So if we graph this on a calculator, and then we're going to use the zoom fit. The reason zoom fit works better for this is because of the fact that they're big numbers. Okay, but you know, 1250, you can be like, okay, if it's going down by 1250 to 20,000, my window's going to have to be kind of way zoomed out, right? Because I need to see more numbers. Okay, so let me show you what I'm talking about here. Let me open up the calculator real quick. All right, so we're going to do this together here. So we're just going to put in, 20,000 minus 1250t. And t is the same thing as x. That's why it actually has a t there already for you. X, t, theta, or n just means any variable or independent variable. And so when we graph this, like wherever my window's at right now, you're going to see I don't see much. Okay, what do I have? 2 bars here? I got something going on here. Let me go look and see. Oh, I have an x squared, that's why. Yeah, it's just an x. Oh, wow, oh, I see what it did. All right, we're almost there. All right, now we'll try it. Well, it's going to tell me go to. This thing's all messed up. I'm just going to put it back in here. All right, try it again. 20, 1, 2, 3. So that's 20,000 minus 1250 x. Graph. Okay, so it does graph, but we can't see anything because it's way up in the 20,000s. Right now, I'm on my negative 10, 10 table, so I can't see anything. So this is where I know like if you have smaller numbers, it's a little bit easier to kind of like bend around and see what you're doing. But see here, your table here, 0, 20,000, 1, 18,000. It's showing you the values. So if you think you're comfortable in adjusting your window so that you can see that, sure. But the zoom fit is pretty effective in terms of the bigger number stuff. So it's down here, all the way down at the bottom to, I think it's 0. Right there. You hit enter, and then it zoom fits it to the little bit better picture for you. The only thing you can't see right now is I can't see the x-intercept very well. Okay, that little dotted line makes me feel like it's kind of close to there, but just making sure you know what you need. Okay, but this is a pretty good picture for now. Like the only thing I might change, because what happens is they change your window for you. If you go to your window, see it has it changed for you. So I just might make my my y min. I might make my y min like negative 10, because what is the y-axis? Let's talk about this for a second. Just in general, with this picture, what does this represent when it goes through there? We talked about this during the problem last time. Nope. When this goes through, what does that represent? Yes, it's the x-intercept, but for this problem in terms of the car.
When it's worth nothing.
Worth nothing. Good. So this is when it's worth nothing. So I do kind of want to see that. So I'm going to go over here and just, I took the zoom fit. I'm going to adjust it a bit. I'm going to make my y min, whoops, make my y min like negative 10, just so I can see 0. You also can change your scale to like 5, maybe 10 even. Okay, so what do you know now? See, here's what I get a little, my program kind of shows me, but what's the problem now? So I need more. I need to make my x's bigger. So I'm going to go make my x be, let's just go with 25 to make sure we get it. Do we get it? Let's see. See, now we can see everything. I made 2 adjustments. Okay, what adjustments did I make? Yeah, I made the y so I can see the bottom of the y, so I can know when the car bottoms out in terms of value. And then I made the x more visible so we can see that actual point. So when we look at our graphs right now with our calculator, what is the main information that I can see now after my adjustments which I wanted? Y-intercept, x-intercept. Okay, let's see if you can get this one. So the x-intercept we said is the bottom out price. It's 0. Obviously, we can't go in the negative. Nobody's going to pay us I'm not going to pay anybody for my car. Okay, what's the y-intercept represent again? So what does this value right here represent? Original value. Josie bailed you out. Okay, original value. That's okay. That's all right. Yeah, you got to phone a friend there. Okay, does it make sense to plot this part of the line or to keep track of this area? Why? Okay, well, yeah, but there's one key factor. What's the x-axis represent? Nope, just the x-axis. Like, what is it in terms of the variable? What happens if we go behind? Yeah, we can't go back in time. That's negative time. We can't go back to the future. We can't say, oh, well, 5 years ago, my car was worth this, because this car, in this case, is brand new. Okay? So just keep those things. That's kind of logic things I don't want you to miss when it gets to quizzes and whatnot. Okay? All right. Let's move this over a little bit. All right, so we just did a lot of this stuff it already told us to, so hopefully you drew that as I was calculating it. So you should have had that picture going here. Okay, I want you to sketch that graph. So I'll let you guys put that now. That's what it asks you to do here. If you still have that graph picture that we just made, please do the 0 feature. So do that again from earlier, from yesterday, and from our warm-up. Do the 0 feature to figure out when the car bombs out. Want to look at it? Okay. So you guys did this here. So calculate the t-intercept of the graph. The calculator, you guys got 16, right? And then we talked about this already, like over and over. That's when the car is worth nothing. Okay. As we keep going here, calculate the v-intercept of the graph using the calculator. So all to do that, all we have to do for that is we just go trace 0. Yeah. Trace 0, boom, 20,000. That is, like Josie said, that is the cost of the car initially. Okay, are you seeing the applied piece here? Yeah. Okay, no, okay, well, keep looking at it. Use the trace feature of the graph calculator to determine the car will be in 5 years. So in 5 years, trace 5, enter. What do we get? 13,750. Good. Thank you. Use the intersect feature of the calculator to determine when the car will be worth half the purchase price. So remember that is, we're going to put, this is where it's a little tricky. Your Y1 has this right now. 20,000 minus 1250x. In Y2, what's half of 20,000? So you want to figure out when these intersect. Go ahead and give that a try. So you're going to put 10,000 to your Y2, and you do the intersect. First curve, second curve, get it close. Okay. What did we get there, guys? 8. You guys got 8? Okay, so that means it happens at x equals 8. Okay, so in 8 years is worth $10,000. Right, appropriate domain and range for this function describes the value over time. This is where people mess up, guys. You can't write illogical things. What I mean by that is, does this line go on forever in your graph? Yes. Does it go on forever in real life? No. Your domain should be 0 to 16. Why did I say 16? Yeah, 16, it's worth nothing. Okay, so your domain, remember domain would be x is greater than 0, less than equal to 16. That's how you'd write it. You can write it as 2 inequalities if you want. Okay, so if you're confused, remember this is the greater than equal to. This is less than equal to. So the greater than's facing the x, the less than's facing the x there. What about the y? What's the range for the y? So this case, range is value, right? 20,000 to 0. Good. I'm putting y, but the the variable is v. I put x, the variable was t for this problem.
Do you mind if we change it to x and y?
I don't. Because to me, that means you're saying independent variable, which is just as good. Okay, just got one more page here, and then we got the next one. All right, so this one, the height of a human cannonball, cano, I guess is what its nickname, can be described by the formula 12 plus 16t minus t squared, where h is the height in meters above ground level. Okay, cano is projected out of a cannon from the top of a building and lands on a soft mat. Mat's placed in a hole in the ground so that the top of the mat is level with the ground. Okay, so we're going to display the graph first. So we're going to put this in our calculator and see what this looks like. So let's do that. So I'm going to go y equals 12. So clear that one out. 12 plus 6x minus x squared. Okay, I'm going to hit graph, and my graph's going to be bad because my window's still from the one you guys just used. Our window's too big. So what I'm going to do first is, these look like pretty normal numbers to me. So I'm going to go ahead and I'm going to go window. You can go zoom fit, but I'm going to go negative 20, 20. I'm just going to take our regular graph, and I'm just going to go a little bit bigger is all. Scale of 2, negative 20, 20. I'm going to go by 2s. I have a pretty good picture of the graph now. You can see almost the whole thing. 25 would have been a little better maybe because I can see the whole curve there. Okay, but that's your picture. That's the flight of the cannonball. Okay, parabolas, main thing with parabolas, guys, those are velocity and like in terms of gravity. Okay, that's kind of what you'll see that in physics. Okay, so that's what it looks like. So we can sketch that here. So we see it's a parabola that kind of does this here. Write down a window setting which is appropriate for the situation. This is what I wrote down. You could have tried something different, but I did negative 20, 20, scale of 2. I did negative 20, 20 with a scale of 2. Again, this could have been maybe 25. Would have been just a little bit better so you can see the top of it. We sketched it. What is the height of the cannon above the ground? So that's, what does that represent? Where is that in this picture? Where's the cannon at? Right here. Your cannon is shooting, like whatever, it's obviously going to be shooting up a little bit more, but it's shooting like that, right? It's shooting the cannonball. So where this height is, where the ball came out at. Okay, because it's not coming from the ground, it has to be in the cannon, so it has to be elevated. So you need to find the what? The y-intercept. The y-intercept is where the cannonball comes out of the cannon. Luke? Okay, double check that you have the equation in there right. But, I mean, in terms of, I know it's what it is because we have, I mean, right there is where my cannonball, that's where it's coming out for mine. So remember, how can we find that? Trace, 0, enter. So 12 is the height of the cannonball at lift or projection. So, yep, your window's just way too big. See that bottom there? Yeah, you want to change your window. Okay, so Luke had a really, really bold y-axis, which means his y-axis is a little ton of numbers. So he had way too much. Okay, so I need to shrink it down a bit. Any other questions on that? So our first thing again, the cannonball comes out at 12. What'd they say? Height is meters. So 12 meters. So you put 12 meters right there. What's the maximum height the cano reaches? And how did you find that? Okay, so you don't want to guess. Okay, but in that picture, guys, I'll show you how to do this. We want this height, right? Everybody ready? Does everybody have the picture of the parabola right now? Everybody's got the picture of the parabola? Hit second trace right now. I'll do this with you. Second trace maximum. It's very similar to the 0. See how it says left bound? Bound. Here's the maximum. Am I left of it? Hit enter. It says right bound. I need to get on the other side of the hill. See, I'm on the right side now. Doesn't matter how far you go. That's fine. And then it says guess, so I get close to it. I hit enter. The maximum is at 3. That's just round that up to 3. That is 3 seconds, 21 meters high. So 21 meters is the max. Very similar to the 0, to find the 0, okay? Okay, good. So what's the maximum height? That'd be 21. How many seconds does it take to reach the highest point? We just answered that, 3 seconds. To the nearest hundredth of a second, how long does it take Cano to hit the mat? So when does it hit the ground? Right, so do the 0. Okay, see how we're seeing what it's asking for, but it's not saying find the x-intercept? You have to make that translation. Okay, so somebody do that. Let me know. How high is Cano 1 second after it's launched? So that would be trace 1. We're just finishing this up here. So in words, they mean here is time is independent, height is the dependent. .6 is when it hits the mat. Like 7.6 seconds. Okay, that sounds reasonable to me because halfway was 3 seconds-ish, so that's good. Okay, and then what you have to do is, how high is Cano 1 second after it is launched? So you're going to hit 1, 17 meters. Now here's the tricky thing. When will Cano be that height again? If you're saying, well, what do you mean? Well, you just figured out that right here, it's 17. Yeah, when is it 17 again? So how can we do that? Somebody impress me. How would you do that? Intersect exactly of 17, but you'd find this one. So what you're going to do is you're going to have your y1, the thing you have up top, y2, 17. You're going to do intersect around that there. That's where you're going to guess. We don't need the first one. We already have that. What's that? It's 5? Good. Okay, so that would be 5. We'll double check that, but it sounds good to me, Raj. Everybody good? Perfect. So this lesson's done.